But again, if they invest all this phishing training, why not tell them this one trick? The plan is to watch the video I released last. So this is going to be the phishing video, specifically a bit focused on the Steam phishing page as an example, but just generally I want to talk about phishing. And of course, we are not only focusing on that video and just watch it, but I want to add additional commentary, additional context about this video, so that this video is going to be, or this stream is kind of like, you know, additional context, a little bit more information than just the YouTube video itself. Before we head into this video, I want to provide a little bit of context about two other things that I did a while ago. And the first thing is actually a video that I never released. Some of you maybe are patrons or YouTube members. In that case, I think I shared that video with you sometime. So if you haven't seen it and you are a member, so you have to look like in the backlog a little bit or something, you should maybe be able to find it. But it's a video about phishing, but I never released it. It wasn't just too good. But in that video, I say something which I think kind of sets the tone for everything. And so I wanted to show you a short snippet of this exclusive, unreleased video. Most serious, in quotes, hacks you hear about happen because somebody fell for phishing. It is one of the most used and easiest methods because anybody can do it. Phishing, as lame as it seems, is one of the most serious issues we have. So many people get phished constantly. In the news, hacking is always portrayed so scary. But most of the time, it's literally a victim falling for a phishing email. So you could take this really seriously. Yeah, so this video was about somebody sending me a terrible phishing attempt. But yeah, the thing that some people might not really get is that phishing is one of the most serious, in reality, like has the most serious impact for kind of like security and hacks. A lot of the big hacks and stuff happens because of phishing, in the sense of where you send a phishing mail and they, you know, go on a website and enter their credentials, or maybe the slightly different phishing. I guess it's not technically phishing, you would call it differently, but the same way where a person gets convinced to execute a malware or so. This is like not really technical hacking how I like to think about hacking. It's not the cool, you know, exploits and vulnerabilities and stuff. It's just tricking people, being a trickster, being, you know, a fraud, being a liar. That's kind of what phishing is about. It's obviously very effective because people can be manipulated. And so because it's effective and so easy and so cheap, it is one of the most widespread, you know, things. And so that also means it is serious. So because it is so easy, it's technically so easy and everybody can do it, it feels so, well, let's just do it, right? It's so easy. But you should not forget that doing a phishing attempt can be really considered as like a serious attack on somebody. You know, if you are able to phish Facebook credentials, those credentials are basically, you know, access to a whole person's Facebook identity, and maybe their whole life with private messages and everything. So yeah, it's a serious thing. So that's why, even though it's so technically basic and so boring, it is something serious that I think a lot of people don't really feel the gravity of what they are doing, for example, if they play around with phishing a little bit. And this is the paper that I referenced in this old video, but also referenced in the new video as well. It's a paper that I stumbled over. It's from 2017. It's about how do accounts actually get hacked? Like, what is the reason why your Facebook account gets hacked? And it looks at three things. And here's the summary of it. So credential leaks is when your credentials were part, you know, like you use the same password and some kind of online shop where you use the same password is hacked. then you just reuse the password and you log into their Facebook account. So you can see this is actually the most serious issue. So people reusing passwords is the most serious issue why accounts get hacked. In this time frame, at least, it was. So this is made by Google, for example, by Google authors, I think somewhere. It's specifically, of course, looking at how like Google accounts get hacked, I guess. And so, reuse credentials are the most serious issue. That's why everybody says unique passwords. That's why we say it's okay to use a password manager where you centrally store all your passwords, or why it's okay to write down your password on a piece of paper, because it is so important that your passwords are unique, and whatever it takes to make your passwords unique, even though you want convenience, that's why you use the same password. So whatever else is convenient that makes you not use the same password, even though it's all centralized in a single file or saved in your browser or whatever, that's still better, because it's one of the biggest issue. But then after that comes phishing. Phishing is the other big reason why accounts get hacked. And then keyloggers, which is actual malware that you install and run on your machine, is even less. So phishing is really serious. And from the perspective of Google or any other big internet company that has accounts and cares about account security, phishing is one of the big threats. Okay, if you can somehow lower the risk of phishing, and credential reuse and so forth, you have massive impact on accounts not getting, taken over and compromised. And so with that, there's one more thing before we head into the phishing video. And that is, a while ago, there is this general discussion about hacking videos on YouTube that get deleted and banned. This particular was about a case in 2019. And one of the hacking policies, so videos that you can't make, topics that you can't make videos about, is kind of like step-by-step phishing explanation. And the reason for that is because, phishing is such a serious thing. And back then, I kind of like made this claim, and I made this video, which is you can find on the second liveoverflow channel, where I just explore a little bit what it means to make ethical hacking videos. And the way I think about those things is, I think the reason why my videos do not have issues, and is the reason why other accounts get taken down. And back then, I made a quick survey where I basically made up video titles, and you can guess what the video then contains. And then I asked people, do you think that's an ethical video or is that an unethical video? Basically asking, is this okay to be deleted because it's unethical or not? And one of the first questions I asked here was how to create a Facebook phishing page. So this was, imagine this is a YouTube video. So is this an ethical or unethical video? And I just want to play you this short clip here. There are more questions in different videos, but I want to focus on this phishing example here. So be open-minded, see what I'm saying here, and yeah. The first question is also related to what I mentioned in the main video, is a Facebook phishing page tutorial video bad? Most people did say that it's kind of unethical. One person said it is ethical. A lot of people also said it's neutral. But phishing is one of the massive problems we have. Google, as a company that needs to protect their customers against phishing, see this as a big problem. The most serious hacks you see in real life are often started with phishing. And yes, phishing is absolutely lame and stupid and shitty, and it's nothing special or secret or crazy or technical or skilled or whatever. But fact is that phishing is a massive problem, and it is used to steal a lot of information, get access to accounts, compromise accounts, and so forth. So I understand that Google and YouTube is very careful with that, and I personally also think such a video is completely misdirected educational. I I personally, it makes no sense. I would not make such a video. What if somebody searches for that, how to make a phishing page, I want to do this sounds cool. I, as an educational YouTuber, I feel like my responsibility is it to not show them, oh, here's a step-by-step guide, here, copy and paste, but to redirect their motivation to web development. A web developer who just started with a few basic tutorials will be able to make a phishing page after the first week. Why would you hide the underlying skill that actually underlies the skill here, which is just programming? Why would you hide that from them and shroud it in some kind of step-by-step tutorial if you can just tell them the true skill, the true knowledge, the true secret behind it, which is just learn programming? So that's why I think such a video is just like a kind of a cash grab, just attention seeking, and in the face of it being directly used in kind of this illegal and compromising way of phishing Facebook, I will tell you right away, there will, depending on how many viewers you have, we are talking on YouTube here on thousands and tens of thousands of people that might be able to see it. I'm telling you, there will be many kids that create a Facebook phishing page and try to phish, for example, their girlfriend or their friends, and then to read their try to get access to their private messages and so forth. That will happen, and you give them direct solutions for that in that way. I think that elicits, or I guess supports, or might motivate some kind of illegal behavior. That's why I generally think it's more an unethical video to make. Yeah. So my main point about why I think having a step-by-step guide how to make a phishing page is stupid is that it's kind of like, for me, misdirected educationally. The real skill of creating a phishing page is web development. And so my question is, why not tell people that and tell them how to do web development? If you really care about education, if you really care about the real knowledge to be out there, then it would be a phishing page that says web development. And so it makes no sense for me to create this video. I think it's comparable, obviously less severe, it's not that critical, but it's comparable to a video how to make a bomb. You could obviously really attention seeking, cash grab, kind of like get the views, get all the information, make a video how to exactly use some kind of cleaning products to create a makeshift bomb. You could do that. This information is, it's not impossible to find it, but you could make a step-by-step tutorial, and so a dummy could follow that. But that is very irresponsible. And now you could say, well, this is censorship. Why can I not share how to make a bomb? Why am I being censored? But in my opinion, it's not censorship, because you can just go to university and go to any chemistry course and sit in there and learn about chemistry. University usually are open. You can just walk in and listen to the professors and chemists to talk about chemistry. You can learn everything, and then with that knowledge you could build your own bomb, probably out of cleaning products. So the real knowledge is not hidden. It's just very, very directed towards criminal, or unethical or immoral, whatever activity, and it doesn't make sense to me. I understand why you do this for attention, and I don't know, you want to sound cool or whatever, but the real skill in phishing is about web development. So anyway, I'm talking way too much about this. It's not really the topic of the stream. It's just an opinion I wanted to share again, because I don't know, that's kind of important to me. Now, there was one comment about open redirects in Google or YouTube, and I'm not going into that, but open redirects are not a security vulnerability. That's my hot take. Stop reporting open redirects. It's not a vulnerability. At least that's my opinion. There's a huge Twitter thread and huge discussion about that you can find on my Twitter if you want to hear about that. I probably will eventually make a video about that as well. Then maybe this is the time where we can talk about that on stream. How can you protect yourself from phishing? I work as a security consultant. I'm a professional hacker, and I wanted to tell you what you have to look out for.
But before you listen to what I have to say, why don't you share in the comments what you do to not get phished? And then after the video, you can check if you do it like me. Phishing describes an attack where somebody tries to trick you to enter your login credentials on a fake website. The website might look and feel like the real website, but the actual domain is different. When entering the password here, you basically give it to the attacker voluntarily. I mean, not voluntarily, the attacker tricked you, but this is actually extremely simple to do. Every beginner web developer can do that within the first week of learning programming. It's very simple, but extremely effective. Besides reusing the same password on different websites, phishing is the main risk of getting your account hacked. So how can we make sure to not fall for those tricks? How can we know if we are on a trustworthy site or on a fake phishing site?
So how do you establish trust on the internet? How can you trust the website you want to access and the website you want to enter your credentials into is the trustworthy site you believe it is? That's the core question in phishing. And there are lots of ways how people try to fight against phishing. Email providers have phishing filters or spam filters. There are people that have local agents like antivirus kind of programs, browser plugins or extensions that try to identify phishing. These are all best efforts, but they are only best efforts. And in this video, I want to introduce basically the only real source that is able for you to identify if it's a real website. That's what this video is about. We are ignoring all the, I'm mentioning a few later, but we are mostly ignoring all the stuff that could identify a phishing link, because in the end it doesn't matter. In the end you need to be able to verify that's the real site, and that's what this video is basically about.
I actually already mentioned the solution. Look at what's the difference between the real website and the fake website. It's the domain. This is the most important security indicator you have. In fact, it's the only security indicator you have to determine if this is a real website or if this is a phishing website.
Yeah, the URL is the only way how you can identify if you are on the real website. That is unfortunately how our web works. And there are lots of people that say, well, it's very technical, URL is difficult to understand. I cannot explain my parents how a URL works. I understand that. It sucks that we can't. It sucks that the web works how it works. But that's really just the only thing you can trust. That's really the only real information that tells you on what kind of website you are on. And it's not foolproof. There are obviously there are like address bar spoofing bugs or that happened in the past. But I think as browsers generally understand that the address bar is the source of trust for everything. Like that's the most important thing. In terms of that allows us to identify if we are on the correct website or not.
So you have to look at the URL to find the domain. But understanding a URL is not simple. It's actually pretty hard. Even for computers it's hard, and we expect at least them to understand it. If you are curious, I made a video once about how freaking hard is it to understand a URL. But it's a very technical video, so no need to watch it. But luckily, as a user, we don't have to go this deep into it. Even though this URL is extremely long, the browser helps us to identify the part that actually matters to us. It's the domain name here. You see that the browser is highlighting the important part with a lighter color and shows the less important part in gray. As you can tell, this is the login page from Google, and I'm using the Google Chrome browser on macOS. But you might be using a different operating system and browser. So let's look at this page and URL bar in different environments.
So there were 2 comments in chat I want to address. First of all, the question, if URLs are hard to understand for most people, shouldn't they be changed to make them more friendly? And yes, this is exactly what the browser does. The browser is highlighting the important part. Again, this is for a non-technical user who just uses the browser for the first time. They will not understand that this is like security-wise important. But and again, it sucks that it's a bit of a technical thing. It sucks that it's not, I don't know, you know, like the world could look differently, right? On a mobile phone, you have apps. People install their Facebook app and they just use their app. It's secure. Okay, how could you phish somebody using apps? There are only 2 ways. Use the browser again. Now we live in a world where a browser even exists. Imagine web browsers would not exist, websites would not exist, then you would only have apps. So to get phished, a person would have to actually install some kind of malicious app that then suddenly fakes to be Facebook. That is like so unlikely to happen, right? At this point, if you install a malicious app, you can maybe do more. On the other hand, mobile phones are pretty like restricted. The apps, malicious apps can't do that much, but it is the web just sucks for this. Like, I'm sorry, I have nothing else to tell you, but non-technical people, I believe, need to be educated on this small technical thing. Like, that's kind of like the internet driver's license that you need to make, okay? Like, this is something that I feel like every child has to learn in school. For me, there's no way around that. For me, there are a lot of other protections you can put in place to protect these people, but if you really want to give them to understand and to basically get 100% protection, then this is like the only real like trustworthy kind of way to go about it. Now, there's another solution, obviously. For example, auto-filling in passwords based on the URL, like password managers, they do that for you, essentially. But the root of everything is the URL. The root of trust is the URL, and you can implement some other. Anyway, we get to that in the video. So that was the first comment. The browser makes it easier already by highlighting, and we will get to a few other examples in that in a moment. Then somebody else posted this link here as a way to kind of like as a phishing attempt. And here it's beautiful. You can see why you cannot get phished by this, because the browser is highlighting the domain and is properly highlighting that this is the top domain, hack.com. So if you are looking for the highlighted part, you see hack.com. You don't see accounts.google.com highlighted, okay? So this is how the browser tries to tell you and explain to you that you are on hack.com and not on accounts.google.com. And again, every browser does it a bit differently. Browsers change over time as well. So here I'm showing kind of like the current state. And so this is obviously Chrome right now, and now we look at a few different browsers just to get a feeling for how these URLs looks like.
Here, for example, is the Edge browser on Windows and an older version of Edge. As you can see, Edge does it similar to Chrome, highlighting the important domain part. But check out Firefox. They also highlight the domain, but only the main top domain. It does not include the subdomain when highlighting. This is a phishing website.
Oops.
Google Chrome.
Yeah, so you can see browsers do it a little bit differently. Edge is also highlighting it. It's obviously light mode, so it's like not so visibly that this is like the darker part. And then Firefox does it interestingly. They just highlight the top URL a little bit like the phishing part here, so that you know exactly you're on google.com and that subdomains are not really confusing you. Again, like you could do long subdomains like this. And if it would all be highlighted, then you could maybe, make it so long that it's like pushing the real domain to the side. And if it would all be white, you could maybe get fooled. Things like that. So, yeah. Now, there's one important detail for the more technical people of you that I did not mention in the video because I didn't feel like it's necessarily important. There is actually something called the public suffix list. And this one is kind of crucial a little bit to this whole debate, because a lot of websites nowadays use subdomains for their customers. So the subdomain is then controlled by other people, right? So think about this. A domain, think a way that, you know, the domain is ending in a TLD, you know, .org. Ignore this. It's just a name and there's a dot and something at the end, right? You could if .org is like the suffix, and then all the customers that want the .org domain, they buy their own domain names. So you know intuitively, because you have used the internet, that everything, or like all the different things before org, like whatever is here, those are all different websites, right? These are all different websites, all different companies, all different people. You know, you understand that these are not trustworthy, right? Like these are all different websites, even though they all end in org. It's not like there's an org company that controls that. So now there are some websites, for example, I believe maybe Blogspot. Anyway, they're like domains that act kind of like TLDs. They act kind of like .org, because when you get a blog on Blogspot or Blogger, you get a Blogspot URL with your own subdomain in the front, and then basically the blogspot.com at the end becomes the TLD, so to say. It's called the effective TLD. If you look at the where did it go? The public suffix list. Where can we find the list? Let's see. So here you can see the list of public suffixes. So if we look, for example, for with google.com is, for example, a public suffix list, because I believe, as far as I understand this from the outside, I'm not working at Google, of course, or Google APIs is, I guess, a good one, or AppSpot. Okay, sorry. No, AppSpot is the better example. AppSpot is for Google App Engine. So customers get their own subdomains in front of AppSpot. So obviously, you want to somehow signal that this is not a trusted appspot.com, right? Like these are all individual customers. So this is basically the effective TLD. It's like .com, it's just .appspot.com, like co.uk, right? It's just like 2 dots now at the end. So this is what the public suffix list is for, to identify what is the effective TLD, so customers are properly separated. This also has reasons for the public suffix list, mentions it for super cookies, because this also influences how cookies can be set on the domains and how they apply to the like subdomain and the parent domain and so forth. But it also, I believe, it's driving the decision what the browser highlights, because this list tells you what are individual customers and what belongs to the same one. And I believe, I didn't verify this, but I believe the reason, so these are obviously Chrome, so they do their own thing, it's Google, but I believe Mozilla is highlighting only google.com because google.com is not in this list here. It's not a public suffix, so it's not their own TLD, which means any subdomains below it really belongs to google.com. These are not other customers, these are not other people. You know that everything, any subdomain below google.com is really from Google. That's why they only highlight the important part. That's what I believe is happening here. And then for their own domains, they just seem to do their own thing. I don't understand, but at least the Mozilla behavior is, I think, explained by that. So yeah, I have here Mozilla, right? I'm not using Chrome here. So if we do something like ast.appspot.com, I believe, see, it's highlighting here the whole domain, while on hack.com, it would only highlight this. And this is because of the public suffix list, I believe. Because it understands that this is the real domain and everything below it is controlled by this top domain. But appspot.com is listed as the public suffix, so it understands that this is a different customer from this, and that's why the whole URL is highlighted, because you need to look at everything and not just appspot.com. Does that make sense? And I would expect that, yeah, then everything below that is again grayed out, because you can assume that this is controlled by this person. Did this make any sense? I feel like I didn't really explain that well. GitHub Pages. Yeah, GitHub Pages is a good example for that, definitely, for sure. So now let's come back to this video. So now we understand a little bit more about URLs and why or how the browsers choose to highlight certain parts. The long story short is you look at the highlighted part. That's the important part. All the rest you can basically ignore.
Maybe Firefox is helping us a bit more in this case, because to verify that you really log into google.com and not a phishing site like google.com with a 0. So this kind of tells you to generally compare from the right. This is the main part and the most important part.
So this was also important for me to explain. The trust from domains is kind of like starting from the right. This is the top domain. And you need to mention this because we intuitively, we understand domains. We understand that we have to read them from the right. But if you ask, like if I ask my parents, they read typically from the left to the right. So they would start reading from the left. And obviously that is bad for domains because kind of like the trust is coming from the top domain and then going down with the subdomain. So you need to read from the right. So that's why I included this. This is important information. I think that you need to look at the domains from the right.
So now that you know that the domain is important for you to check if you are on the correct website, let's look at a browser on an iPhone, because here is something interesting. Here is Chrome and Safari. Look at this. They are completely hiding the full URL and only show you the important domain. Here you can clearly see, without getting distracted or tricked, that this is indeed google.com.
And yeah, I mentioned this also just a moment again. The other browsers do this obviously as well, but on mobile, like this is really great, right? You do not get distracted at all. You see the full domain. Now here, this one trick the person earlier posted, you know, when you do like a long domain and it goes out to the side, that could still be tricky because on a small screen, you might only see, you know, like the starting part here. So something like this could still be misleading a bit, but yeah, it will then also kind of look weird. Again, once you know what to look for, that you need to understand and trust, you know, check that the domain matching, that should be fairly easy, I think.
So it's safe, and actually this is what Safari also does on macOS. It also hides the URL path. I know many technical people, including me, like to see the whole URL. For hacking, it's important. But to be fair, for regular users who might be super confused by the long, complex URL, only focusing on the part that matters for security, the domain, this is pretty good. Actually, recently Google was running an experiment on Chrome to also hide the URL path, like Safari, because they wanted to see if it helps with security for the general public. But after a while, they concluded that it didn't improve important security metrics. So apparently it didn't really help to prevent more phishing. And I can see why. I think people who understand they have to look at the domain name will be fine with the highlighted version. And for those who do not understand this, they won't magically learn this from just seeing the domain.
This is a discussion I often read, and I often smirk when I read it. Once in a while, browsers start, you know, hiding the full URL, and then tech Twitter just explodes. And holy shit, you can't hide the URL, it's so important, and I want to see the URL, and it's important for security or hack. I don't know why it's important, but people get really heated with that. When browsers want to take away the URL path and hide that, they get really, I forgot the word, but they get really angry. But from a security perspective, it is kind of the best thing to do, at least it seems at first. to hide the unimportant part and not let people get distracted. You know, people talk about things like long subdomains or hiding stuff in the path, you know, like having some URL encoded stuff at the end. It's all unimportant, you know, people will not understand it. People shouldn't care about that, at least in terms of using the internet safely. So I think for the general public, it's probably a good idea to hide the full URL and only focus on what is important for security. As long as there's a way how I can still see the full URL, if I need to do that for my work and all that stuff, it's all fine, and that will still be the case. Developers need to see the URL. Browsers will never get fully rid of that because developers need to see the URL. So it is a good idea. However, as you just heard, Google did an experiment and tried this and looked at measurements if it actually improved security. Did people fall less for phishing because of that change when the URL is hidden? And this experiment showed no. But this is also not surprising to me because you think about a person who has no technical knowledge. Seeing this, just like this, how would they know that they need to look at that to not get phished? How do they know that they need to look at this URL? They won't know. The browser or how the internet works just doesn't make this intuitive and clear for users. It's something that you need to be told. Somebody needs to teach you and tell you you need to look at the URL. And once they have this knowledge, then hiding this makes it easier to not get distracted or confused. But you still require this knowledge that you even need to look at this and need to care about this. So that's why, I guess, that's my assumption why it didn't change anything in terms of phishing, because either people know to look at the URL and then highlighting the important part is already enough, or people don't know they have to look at the URL, then hiding everything also doesn't matter. That's kind of like my take here.
Just seeing the domain. So now I think you understand where you have to look and which part of the URL is important. Thanks to the browser highlighting parts of the URL, you know what the domain is. So how do we now use this knowledge to prevent phishing? It's kind of simple, but you need to be vigilant. Basically, you have to do the following. Before you type in your password, practice to always look at the domain. It doesn't matter how you got there. Maybe you clicked on a link a friend sent you. Maybe you clicked on a link on Reddit, or you clicked on a link in a phishing spam email. But before you enter your credentials, you need to look at the domain. And now you need to ask yourself, is this the correct domain? Let's do an example. So here is a login to the popular game distributor Steam, and it looks very legit. This looks like the Steam page. And if you just glance at the URL, maybe not really looking at it, it looks fine. Steam community, that is the correct domain.
So now I mentioned that it's important to look at the URL, and now we do a practical example how we actually do this in practice. It sucks. There's no magical bullet. In my opinion, this is the only way how you can prevent phishing properly. And this requires this little bit of education, and I hope my video helps educate people on that, and they should be fine. And yes, I see comments already. It's not Steam, it's Steern. But, you know, if you just click on this, it looks fine. If you intuitively, if you visit this page a lot, you might, have a feeling for how the URL is supposed to look like. And if you just you're like tired, you head on this website, this URL on first glance, like you don't even look at it, you look at you are here typing your password. It doesn't look unfamiliar. It doesn't look too weird, or might not look too weird if you don't look too closely. So you can fall for this. This is how phishing works, right? Like having the URL just slightly different, looking kind of trustworthy, and it will work. I mean, this exists because it works.
But we just learned that we need to be careful looking at the URL, and upon closer inspection, we see something fishy going on. It's actually not
What a great pun, huh? Something fishy going on.
Steam, it's STRN. the small r and n look like an M at a glance. This is very tricky, and the letters are switched here, the community is misspelled. So this, of course, is already suspicious and reason enough to immediately leave the site and not enter your password.
So again, so this is like a sanity check. There are, when you read up on tips to protect yourself against phishing, you hear a lot about these checks you can do. And this is one check. You know, Steering community is obviously misspelled. You can reject that website right away. So this is a good test to know this is malicious. But I hope it is clear that the inverse of that is not the case. There are a lot of indicators that make you suspicious and you can tell, oh yeah, that's phishing. But the other way around, that is the difficult part. How can you say it's not phishing? Okay? Does that make sense? It's very easy to detect phishing. It's very hard to determine it's not phishing. Does that make sense? And so misspellings are obviously a good indication. You can reject the website right away. But to really, really verify, if you are unsure about this, for whatever reason, maybe, I mean, it's maybe not a good example because of spelling mistakes, but if you are unsure about this domain, then now we come to the real part. The only security indicator that helps is the URL bar and how you verify that now.
But the best check is to compare it to the real trustworthy site. How do you do that? Maybe you have the correct site bookmarked, or you remember the URL, or you can simply Google for Steam. And then you just need to go to the login page. And then when we find the same login page on the now clearly trustworthy site and compare the URL, you can now see that it's different.
So this is the difficult part of this whole thing. You need a way to find the real trustworthy website. This could be bookmarks, this could be your history, because you start typing in the URL in the bar and it just shows up there. It can be, you know, you could give people what's it called, a shortcut on their desktop where they click on it and it opens the right page. Or you can Google for it. Now with Google, you need to be a bit careful because of advertisements that are phishing links and all that stuff. But I would say generally Google helps you to find the real website pretty well. Unfortunately, also not the best. Ideally, you like bookmark your page or whatever, you know, make the effort to, I don't know. You need some way to know, to find the real page. So that's kind of the hard part of this. But then you can compare.
Simply switching back and forth between the page, you can clearly see that the domain is different. So now we know 100% this is a phishing page. And that's it. This is basically what you have to do. You simply look at the domain before you enter your password, and then you just need a way to quickly find the site you know is the safe site. Or you remember the domain exactly and then compare it. Unfortunately, this seems a bit annoying to do, and you probably have a hard time making sure your parents learn to do this. So an easier way is to actually let the browser remember the password for a site.
And here we come to the solution how to do this probably for the, you know, the non-technical people. You tell them to save their passwords in the browser, or you let them save the password in the browser, and they are just let them forget their password. Just not let them remember passwords at all. And just let the browser remember it. Then the browser will compare the domain name and only fill it in if it matches the domain. Now, there have been vulnerabilities in browser managers filling in passwords for the wrong website and all that stuff. So, of course, it's still software. Software can have bugs, okay? But the idea itself is the correct idea, and we just need to hope that it doesn't have other vulnerabilities. Vulnerabilities can always appear, but in general, you can let this comparison be done by the browser. And it's kind of like the thing where when you register, you save the password, and then the browser will fill it in for you. It's the same as if you would register, bookmark the site where you registered on to have like the source of truth kind of for the correct domain. Now you have bookmark, you can compare it yourself later. Does that make sense? So this is the what people should be doing. And I have to say, like, things like the iPhone do this really well. When you are signing up somewhere on a website, the iPhone will suggest a secure, unique, random password. Perfect. You don't need to think of a password at all. You just say, yeah, I want this password, and store that password for me. Perfect. If people trust these devices or trust their browser to store the passwords, they will probably not fall victim for phishing at all, because those devices will not offer you to fill in those passwords. So there are other concerns, privacy. I understand all that, having passwords all in one place, blah blah blah. These are all like other valid concerns. But when it comes to phishing for the general public, that's probably like the best thing you can do.
And you do not ever type in your own password, because now the browser checks the domain for you. The browser will only offer to autofill your password if the domain matches. So this is an easy way to never get phished. That's it. The domain is the only way you can figure out if the site you want to enter your password is the site you expected, the safe real site. Now, I could end this video, but for those people with more technical interest, I'd like to talk about a few other things.
Now we get into kind of like the second part of the video. Now the more non-technical content is over. Just, making people sensible for the URL and how you can find the URL, that you need to compare it, and maybe password managers. And I noted down a few questions that already came in chat, so we can maybe now is the opportunity to look at them. So apart from looking at the URL, what are other measures that can be taken to prevent this from happening to people less tech savvy? As I mentioned, password managers and the built-in stuff from iPhones or the browser are great. If you want to give them another password manager like 1Password or whatever is also probably great. But I guess the built-in stuff on iOS or the browsers is probably the easiest for non-tech savvy people. And then also using, for example, using Gmail. Gmail, obviously, they monitor all the time. Of course, phishing slips through, but they have really good filters in general and so forth. Like a solution like this doesn't take anything, and you will be pretty well protected. I've seen Google being pretty good at placing warnings in emails when they look fishy and stuff. So I felt like the Google Gmail filters are pretty good. So my weapon for non-tech savvy people against phishing would be storing passwords in the browser or their mobile phone with the native offerings, and using Gmail. Kind of like that's kind of my thing. Also, maybe use mobile phone in general and not PCs, because phishing on mobile is a lot harder because people install apps, right? They use their Facebook app, they use their Instagram app. They don't usually even know or remember their passwords at all because they just logged in forever in those apps. And so it's I think a lot more unlikely to get phished on mobile, but that's just speculation. I could also be wrong on that. I would be interesting to hear a study on that. What do you guys think about phishing with open redirect vulnerabilities? Again, I think this argument is dumb, because with my method and what I just explained to you, open redirects don't matter. You click on the link, you get redirected, you're on the malicious site, now you compare the domain and it's different, right? It's all about looking at the domain before you type in your password. And that's the whole strategy, and open redirects then don't matter because you get redirected to the malicious site. So that's also why I consider open redirects not to be an issue. There are a few other things I mentioned in this video later where I will get back to that for just a moment, but yeah, let's move on to the next question. You don't improve security with hiding something. I know why you say this, but let's entertain this for a moment. You do if, how do I explain this? Humans can have information overload, and they get alert fatigue. So when they get constantly warnings and when they see too much information, they will just ignore stuff. They will just click through warnings and whatnot. So in the user experience, like security UX, security user experience, how you design a user interface so people are as secure as possible. And browsers obviously are very crucial in that. They really need to think a lot about security user experience. There it makes sense to be very careful with how they use warnings, when they use warnings, how they display those warnings, what information they hide, what information they present. It's very, very carefully chosen. Of course, for security, we want to be able to have insight, like hiding information at all cost is dumb, but hiding it from the regular user interface can be good. These are very sensible and careful decisions that have to be made when you design a user interface like a browser that is so critical to security. I remember there was a study on the SSL alert icon. Let me see if I can find this. Google Scholar. Let's see. SSL log icon. Measuring SSL on mobile browsers, which is okay. This is not the talk, and this is not what I had in mind, but this is basically what I was thinking about. So these kind of studies exist. So I haven't read this paper obviously, but just based on the title, they are measuring how well the security indicators work to really like if it makes sense, if it helps for security of people just get confused by them. And let's see. Yeah, here you can like see what browser displays what, and they probably did a user survey. Yeah, here you can see examples from these browsers, how they display SSL information or not. You see how different all these browsers were back then. But yeah, this is research. You see here's a research paper on just basically the security indicator for SSL, just this small portion of everything, how it affects like the understanding of people, like measuring the impact of those things. Does it have impact or not? So, it's not as easy as saying hide information or hide not information. This is like a very difficult decision. You need data on that. Yeah. In my experience, it's easy to get phished on mobile if you're using passwords. If you open a link in Facebook Messenger, it will open in a web view integrated in the app. Oh, that's a good point. Yeah. Yeah, I can totally see that why this is very bad. Yeah. No, let me see. I'm curious. Does it display the URL at the top when you open a web view? But if it does so, it will probably be like very faint, right? It happens on Twitter as well. Yeah, you are right. It's really difficult. There's so much. So the screens are so small. I guess the solution to that is do not use passwords and use the auto fill-in from your iOS browser. This way, it will just not offer you to fill it in. Okay, now there was a question about certificates. So first of all, if I do DNS poisoning to force someone to be redirected to my phishing page instead of Facebook, would the network admin be able to detect it? So first of all, the browser should probably prevent you from doing that because you would get an SSL error, right? That's what we use SSL for. But it depends obviously on the equipment and if they have measurement stuff. We also have here, what's it called? The DNS stuff with like the security DNS stuff. Like, I don't know how that all works. Maybe it's not even possible. I don't know. But yeah, but this is like a different attack, right? I wouldn't classify this even as phishing anymore. Phishing is just kind of like the delivery method, what you do. The real attack would be the DNS poisoning. And it was then just used for phishing. DNS poisoning could be used if you can take over a DNS, the DNS of a domain. You could do many other things, right? It's like phishing is just one of the techniques you can then use, obviously, because it's then very powerful because it's a trustworthy site. But yeah, it's at this point it's essentially just man in the middle attack. So yeah, I don't know. Like in this case, I wouldn't talk about phishing anymore because you cannot really defend yourself. I mean, it depends. Again, SSL errors, you shouldn't ignore SSL errors and so forth. But in principle, you're talking here about a very different attack, a very different vulnerability or whatever. I wouldn't classify this anymore as classical phishing, you know. And then, of course, like certificates in general, of course, provide you a lot of information about a site. Of course, they had to get the certificate somehow. Again, you can think of a vulnerability where you take over the DNS, and controlling the DNS, you can get a certificate from, for example, Let's Encrypt. So, you know, you don't know, but then there's maybe certificate pinning or maybe not. And I don't know, it gets fuzzy. Of course, certificates can tell you a lot of stuff, but I don't know. I'm not so sure what else I could say. Anyway, let's continue here with some other takes.
Check out this super advanced Steam phishing page. It looks very professional and trustworthy, but it asks us to log into Steam in a new window. So let's apply what we just learned. We know from earlier that the real Steam login page is steamcommunity.com. We can check the URL and it looks correct. So is this safe? No, this is just a very clever phishing page. This website is faking another window. It's very obvious here because this is a typical Windows window and I'm on Mac, but this could be really confusing to a lot of users. You really have to understand and know that this is your real browser window, this is the real URL bar, and all of this here can be fake. You can test it when you try to move the window around. It moves, but only within the page. For example, it cannot be moved over the actual browser window. So this is the actual URL of the site, which is obviously not the expected steamcommunity.com. So it is fake. That
phishing page is really insane. This is one of these things where you see like proof of concepts. People make example spoofing stuff. Yeah, you know, very famous. There's also, you know, you get the browser in full screen, and then when the browser is in full screen, you just fake the whole bar at the top. That's another way how this could be done. Obviously, there's a full screen warning, but regular users, I mean, they probably get fooled by that. And so this is another way where you just fake a pop-up, and it really looks convincing. And can you look convincing? If you really put effort into making this look native and feel native and so forth, with moving it around. That's people fall for this. Like, this is very powerful. Especially this even gets people that know and understand they have to look at the URL. This is so convincing. Again, like I'm lucky on Mac, like it looks differently. But if this would have been improved to fingerprint the operating system and the browser, and then having, you know, all the different windows matching for your system and all that kind of stuff, this could even be more effective. But yeah, this is probably one of the most difficult things for non-technical people to understand, that all of this inside of the page can be faked. This is just a website. That is the untrustworthy part, and only this top part here is, or basically only the URL bar here is the trustworthy part.
That was pretty crazy, right? Next, let's tackle a technical question some of you probably have. Your defense technique depends on going to the phishing site and comparing the domain in the URL bar of the browser. So that means you already clicked and visited the malicious site. Doesn't that mean it's too late? Well, yes and no. So a lot of anti-phishing and security awareness training teaches that clicking on a link is already bad. They try to make malicious URLs sound very scary, and instead of clicking on them, you should do other checks. For example, check if the URL starts with HTTPS, or look at the domain of the link before clicking, or in the case where the link is not shown, hover over the link and check the URL there.
So this is basically where we come to the open redirect topic and everything. So people say clicking on links is bad. But this is, I understand where they are coming from, why they're saying this, but it's a pretty dumb take, because this is how the internet works. We have links. Everywhere are links. And this kind of, like, security awareness training where you make people scared of clicking links is so dumb because people click links all the time. How would they know which link is malicious or not? It makes no sense. You can, from a link, not determine if the link is going to a safe site because you have open redirects, because you have redirects in general, because here hovering over the site can be faked. If you're on a website, hovering over the URL can display something entirely else than what happens when you click on the link. You can make it, well, let's see, there are other examples here I mentioned really quick.
But check the URL how? Now, it's very difficult to know which part is the domain. It's not nicely highlighted. And
so for example, this email, it's a PayPal email. And, oh, you don't see this, wait. PayPal/communication.com. Is that now a phishing? Is that a malicious link or not? How would anybody know? How could anybody know? Nobody knows from this link. You can maybe see that it's a phishing link, but you could never determine that it's not malicious, right? That it's safe. So yeah, this is
also links can be faked. For example, in HTML emails, the displayed link can be different.
Yeah, here, for example, HTML email, you can just make it, you know, the text a trustworthy URL, but then the anchor tag, it's like down here, it's just going to a malicious site. So again, this is where people say, well, you need to hover over the link and then look where the hover link goes. But again, there are so many ways how links can be deceiving. And this is where we come into what somebody else just shared here just a moment ago. And it's these social links with misleading embedded, what's it called? Social graph things, where this is not a Google link, but all this information is just fakeable. This is just how the internet works nowadays, okay? You cannot, like, it sucks, but this is just reality. This is what happens. There may be some safeguards sites can do, but in general, like in the end, the only trustworthy part is the browser URL bar. So you have to click and then see if it's a phishing page. There's phishing awareness training or security awareness training where they send around mails, and just when you click on a link, you already get shamed for clicking that link. And I think that is so terrible because clicking links is normal on the internet. Clicking links is nothing bad, okay? You cannot expect people to not click on malicious link. It's just, sorry, it makes me, it riles me up. It's such a dumb take to say that you shouldn't click on links because it's just impossible in how the internet works. We just have links, and links can be everywhere, and links can be very deceiving and fake and stuff. You just cannot prevent people from clicking links. The important thing is what they do once they clicked on it, and that you give them tools to identify if they are on a safe site or not. And this one tool is look at the domain. Like, that's the real training. But that's one thing. Phishing is obviously one thing. There's the other argument that you could click on a phishing link and on a malicious link, and you could have a browser exploit that's exploiting your browser. And this is what I will now talk about in this video.
From the one that is actually there. Or seemingly trustworthy URL is redirecting you to a phishing site once you click. And when you do this hovering test, you might be wrong anyway. For example, Microsoft often sends mails with these weird domains. They look cryptic and fishy, and in fact, some people online believe it's phishing. But it's just a link tracker. It's Microsoft.com, so it's trustworthy, and it redirects to a safe site. But this advice is also not completely useless. You can apply all of that, but it only helps you to identify a phishing link early. It does not tell you if it's really trustworthy.
This is again what I said earlier, and this is like my most important point in my whole argument chain, you know, that there are lots of ways how you can detect phishing early. Somebody just mentioned there's this idea of using machine learning. You point machine learning on, like you let it read the safe site, and then when a new site comes in that is potentially malicious or not, it can do machine learning and matching and tries to check if they look similar, and if they are too similar, it will say, oh, this looks like a potential Facebook phishing site or something like this. These are all great measures to not let phishing go through, but all of these things do not tell you if the link is or if the site is safe. These are all things to identify phishing early, but you will never be able to say this is the real site. The only security indicator to tell if a site is safe is the URL. If we cannot trust the URL bar, we are in trouble. So I'm also arguing, obviously, that browsers take it seriously, that their URL bars stay trustworthy. Yeah, that's kind of like my argument.
There are lots of indicators if it's phishing, and it's great if you can reject the link early for being clearly phishing, but there is only one test to be sure it's not phishing, to be sure it's a safe site, and that is to check the URL bar in the browser before typing in your password.
So yeah, Neo, you are saying non-IT people, you can't expect Karen to look at a website. I'm sorry to tell you, this is just the sad state of the internet, that this is how the internet works. The only security indicator to determine if a website is safe is the URL bar. This is the only way to check if it's safe. Now you can, like I said, you can add tons and tons of mitigations so she can detect a phishing page early. You can have automated tools that scan emails. You can have dozens of subscriptions for some kind of anti-phishing and anti-malware stuff that can detect everything, or like can detect a lot earlier, so she doesn't have to even click on it in the first place. But all of these things can only identify phishing early. They can not determine if a link is safe. Does that make sense? You can invest all the stuff, and maybe you say 99% of phishing is caught. That's good enough. For the 1% we do get phished, we don't care. That is obviously an attitude you can have. But the unfortunate reality is the only indicator to check that it's safe is the URL bar. That's just how it is. Or you tell me, how can I figure out that a website is safe? And don't, like, what is the one thing I can do to determine a website is safe? It only works with the URL bar. Either password manager that fills it in for you, or you do it yourself by hand, basically. A Trojan from phishing. I mean, yeah, that's the next issue, that you can, like, that people run malware and open macros and whatnot. Issue with emails, anti-spam, antivirus must not follow links. Yeah, that's an important point. They should not follow links. So first of all, you could say, well, they should follow links so they can analyze the website. But the issue is, if they visit a URL, they already provide the indication that the email is valid, and people are very paranoid about link trackers. So, or password reset emails. Think about a password reset email where you need to or password login verifications, like click on this link to verify that it's really you or something like this. And then now your anti-phishing tool helps attackers to basically automatically click on accepting links. You know what I mean? We had actually a problem where someone got a Trojan from phishing. Okay, so when you say Trojan from phishing, you just mean an email and there was a Trojan attachment. I just want to make sure, because phishing, I understand that people say also it's like clicking on, attachments and stuff, but phishing might more be like, I think more of it as like a website, a fake website where you type in the passwords, and not so much the malicious attachments, because obviously, executing viruses is a bit of a different kind of area. Hox Hunt tool, and now they use some kind of training for catching those links in the email. Essentially, that we are afraid to open links. Probably something like gamified phishing exercise. There's also something I can show you in after the video. Can be probably fine, but I would judge them hard, very hard, if they are shaming people for clicking on links. If the training is about, other I can imagine there's a training to be like, look at these other indicators, and can you determine if, based on these, if it's phishing? And then obviously it makes sense that then clicking the link, you should have maybe detected earlier. That kind of training is, I guess, interesting or fine to make people sensible about, detecting phishing early. But again, if they invest all this phishing training, why not tell them this one trick to look at the URL? You don't need anything else. No other phishing indicators, just look at the URL. You don't need to know anything about anything else. Just compare the URL. That's the only training you need. Just no other training. Just look at the URL. That's like my argument, kind of. And of course, you can always add to that by making people look out for other phishing indicators to not even click in the first place. That is obviously great as well. But the most important, I think, is first to teach how to identify a safe site. So because that will always work. And then you can add on top of that to detect stuff earlier. Does that make sense? Yeah, I understand that, like, to teach detect phishing emails. That is fine, I think. But, I think the important part is to teach the easy thing to look at the URL first. Because then, if they understand that, they can already, not fall for any phishing, because that is, like, in my opinion, the biggest weapon you have. And then you can, obviously, if people are motivated and it's important to you, teach them how to identify phishing early. Yeah, but, I guess you want to sell prolonged training. I don't know. If you click anything in the email, you fail. To be honest with you, I find this terrible. I find this awful. The web works with links. People click on links. They just worry about the wrong thing then. Like you said, you make them afraid of clicking links. And I don't think that really helps for your security. Because, they will just be anxious and scared of every link. And then there will be another phishing link with something urgent. And they now have to juggle their fear of this urgency and their fear of their own thing. And then in the end, they can still fall for phishing because they did not learn how to identify a correct site, because they were only taught weird things about scary links. Yeah, I don't know. That's kind of my opinion.
Actually, besides the domain, there's one more small test you can do. If you click on a link and it asks you to log in, you can open another browser tab, go to the real website, and make sure you are logged in. So if you're not logged in, log in now to the site is safe. And once you are clearly logged in, now click on the original link again. And if it still asks you for your username and password, it could be a phishing attempt, and you should check the domain.
What is special about this trick is that it allows you to identify a safe website. This is, again, this is like I try to make clear. There's lots of stuff that allows you to identify phishing. There's not much that allows you to identify it safe. And basically, looking at the URL bar is the one big thing you need to learn to understand that this is how you identify it safe. And then there's another trick that also makes it clear if it was a safe site. And this is what I showed here. When you get a malicious link, for example, here, check out this document.
If you click on it,
you come to a login bar, and now you can be lazy. You could look at the URL bar. It looks safe, like this is the correct URL. But another thing you could do is you leave that tab alone. You go to the real website. You make sure you are logged in, and then you go back and click on the original link. And if you then suddenly do get through, that means, oh, it was a safe link, and now you can just be wherever you want to be. So that's another way how to identify, okay, that was a safe link indeed. But I thought hard about this. Like, does anybody of you have any other ideas how to determine if a link is really, or if a website is really safe? To me, the URL bar is the only good one, and then this one was another trick, but again, doesn't work in every case. So, okay, so now we talk about, that click on a link, there could be a browser exploit.
Already hack you? Yes, but mostly no. Stop the fear mongering about malicious websites, please. Let me explain why. First of all, it is very important that you use an up-to-date browser. In particular, that would be Firefox, Chrome or Chromium, Safari or Edge. They should also automatically update themselves, so you should not have to worry about that. So why is this important? Browsers are very, very complex pieces of software. It seems simple, just display a website here, but that is very complex. And complex software will always have programming mistakes, which an attacker might be able to exploit to install malware on your device. So to understand why people say that clicking on links is bad, we have to go back in time to the late 2000s to early 2010s. Browser exploit kits were very, very widespread. It was not uncommon that you visit a malicious website and it would exploit a vulnerability in your browser or an extension like ActiveX, Java applets or Flash to install malware on your computer. This was also called drive-by downloads. And once malware is on your computer, they could steal all your passwords. This was even a business model. As a black hat criminal hacker, you could rent or buy a collection of these vulnerabilities in so-called exploit kits. And it was a business model because it was affordable. A black hat criminal could pay a few $100s per month to get access to an exploit kit that contained dozens of vulnerabilities. And back then, browsers were not automatically updated. New vulnerabilities constantly were found, and so this was a real threat. Now, over the years, browsers got a lot more secure, though vulnerabilities are still constantly found. But let me try to explain why it's different today. Here's, for example, the website of Zerodium in July 2021. They are an exploit broker. They buy vulnerabilities from security researchers and sell them to, for example, government agencies. And this is the price list of what they pay for an exploit. For a remote code execution, including local privilege escalation in Safari, Edge or Firefox, they pay up to $100,000. And for Chrome, they even pay up to $500,000.
Important here is that this is obviously the price for acquisition. I don't want to know the price for them selling it further. And then I don't know if they probably don't offer like direct services. Then they might sell it to maybe NSO, and then NSO is offering services of hacking browsers to, a government agency. And though there's like margins and margins up to that, but then multiple users can use the same bug. But like you are reaching ranges where there are contracts worth millions. So yeah, from the buyer side, from the user side. From the user side of these things, you talk like millions of cost.
Now that Edge is also based on Chrome, I suspect this kind of changes now as well. So this means two things. First, I can guarantee you that there exists an exploit for your browser right now. A very powerful attacker could theoretically take over your device when you visit a malicious website. But then how does this make sense with what I say you shouldn't be scared of clicking links? Well, the economics are different now. These exploits are very expensive. It's not affordable anymore by your random black hat hacker who tries to spread malware to thousands of people. So yes, there are still people being targeted by it, but you are probably not one of them. Let's be fair. You are too unimportant, so it's a threat you probably shouldn't worry about. And keeping the browser up to date is the most important defense you can do, because it means older, cheaper exploits are not usable against you anymore. That's probably the best defense you have.
Okay, the best defense is probably disabling JavaScript, because virtually any browser exploit nowadays requires JavaScript. So if you only allow JavaScript on websites you trust, then that's probably the more effective defense. Now, I understand this is like a very difficult take, okay? Like, as I said in the video, the reality is these exploit exists, okay? Like, you have to think about this. Like, these exploit exist. This is very uncomfortable. This is like risk analysis, right? This could happen to you. We don't know. Maybe there's an exploit that might eventually leak again to some black hat group, and they do a, I don't know. Maybe you piss off somebody on Twitter who actually has, is a researcher that has an exploit and he just wants to fuck with you or something. I don't know, right? This is the uncomfortable reality that these things are out there, but the question is, should you put effort into worrying about that? I believe that there are more other things you should be more worrying about. There are other things that are more risky and more likely, but it's still uncomfortable because technically it's still possible, That is what makes it a bit difficult. But I would say, just looking at the past 10 years, how browser exploit kits were very rampant. Even in Metasploit, there's this browser exploitation module that worked with, some older Internet Explorer sites, and that worked with engagements and stuff like this, that you could exploit somebody's browser. This doesn't really happen anymore. So yeah, so for me, my risk assessment is I don't really want to worry about that. But yeah, it's uncomfortable a bit. Yeah, for example, I don't want to piss off I don't want to piss off Itzen on Twitter, because then maybe, Yeah, so yeah, again, it's uncomfortable. I don't know, everybody has to obviously figure out their own paranoia. But yeah, as Itzen is saying, NDAs are more likely in those cases. That's why you need to have up-to-date browsers, because obviously older bugs get published. People create great write-ups of these bugs, so somebody else could put them into into a browser exploit kit. I could imagine that maybe these kind of browser exploit kits also exist for NDAs that you can buy, but also browsers get really annoying and force you really to update, which is a really good thing. So probably it's maybe not even that usable, but yeah.
This also means if your company requires you to use an older browser like Internet Explorer because you have to access some internal intranet application, do not use this browser to visit anything else. For any other website, please use an up-to-date Chrome, Firefox, Safari, or Edge. Now, before I end this video,
yeah, that's also important to me. Somebody asked earlier if I know the browser Brave. I'm obviously not in detail familiar with Brave, but the general rule of thumb is ignore any third-party browser. They are obviously just building on the existing browsers, and it's very likely that they lag behind the patching schedule of those browsers, and you will always have an outdated renderer and your JavaScript engine, whatever. And it's much more likely that you will be targeted with some that you could fall for an NDA. I think browsers are such scary softwares that I just don't want to have some kind of weird skin third-party thing over it. I just want to have the original browser. And Edge, Safari, Firefox, and Chrome are the good choice. And if you care about privacy, if that's important to you and you don't like the Google stuff, then use Chromium or use Mozilla. Mozilla tries to be a bit more privacy focused, gives you a bit more control over things. So yeah, if you are looking for privacy stuff, use Firefox and maybe look up one of these uMatrix or whatever these are called, these kind of extensions to block stuff.
I briefly wanted to mention two-factor authentication. Oftentimes, two-factor authentication is hailed as a solution against phishing, but this is not really the case. It is true, two-factor authentication is an effective mean against the basic form of phishing. So when you enter your password into a phishing site, the password is stored and an attacker can use the password later to log in and take over your account. But a really advanced phishing page can still phish you. For example, the advanced Steam phishing site from earlier. When you have an account with two-factor authentication enabled, the site notices that and simply asks you for the code. So how can this work? Well, it's not different than when a friend sits at your PC and you tell him your username, password, and authentication code, and they type it in for you. That's what the phishing website does too. When you enter your credentials, in the background, the site already tries to log into Steam, sees that the code is required, asks you for the code, and then you can supply it. Now the phishing site is logged into your Steam account and can do anything. This is definitely more technically advanced and requires a lot more coding skills, more than the basic phishing site, but it also is not magic. So two-factor authentication definitely can help against all this basic phishing stuff, but it's not bulletproof. So
yeah, what I didn't mention in this is obviously that you have these other security tokens that are more like integrated, like physical tokens, U2F, whatever. They work with a protocol that I think takes the domain into account or something like this. I'm not exactly sure how it works, but yeah, those would be secure. And for example, Google employees internally have such a token for all their employees, and they virtually have no phishing issues as far as I know. This is kind of like, so if you look for a solution probably for non-technical people but want to give them a keychain thing that they need to use for every time they log in, then probably a U2, like a YubiKey or something like that is probably, yeah. And I recommend everybody else to use something like that for login. Especially, you know, you don't need it for all your accounts, but like your Gmail, you know, your Google account, your email account. Your email account is probably the most valuable and most scary account that you don't want to lose. So at least for that one, that maybe is a good idea to use. Yeah, or at least 2FA, but as just explained in this video, 2FA is not foolproof for phishing like this Steam phishing page did. If you have a bit more engineered phishing page, they can just forward, you know, they can just already try to log in, ask for your 2FA as well, and then log in and do whatever nefarious thing they want to do. I don't know what the Steam phishing page does, but I assume maybe it will trade away all your items automatically in the background once you logged in. But it's true that, of course, most phishing attempts are very, very dumb, and they just save their passwords in a document, in a text file, and later they try it out. Then, of course, the two-factor information is missing. But as soon as you have a more advanced attacker who is really interested in like owning you, they can set up something like this. It's a bit of engineering, a bit of programming, but it's also not magic, and they can still like get around your two-factor authentication. Now, there was one other thing about U2F. So we just mentioned that U2F is like the cool, like the USB thing that does more thing that seems so great. If I remember correctly, let me see. There was a talk. Yeah, here, this talk. I don't know if this technique still works, but basically they created, so basically essentially this phishing page with regular 2FA, they did that for U2F. Basically they if I remember correctly, this was 2018, so it's 3 years ago, so I might not remember correctly, but basically they used web USB to directly send, you know, the real USB, like they implement the USB protocol, and then they relay that, like you plug it in, your device is communicating with USB, they create a WebSocket relay that, so basically when the person plugs in their USB stick, that those USB packets are relayed through the phishing server to the real site, so then it still works. You know what I mean? Maybe they have a picture here. So they show it. So they basically use web USB to directly redirect directly pass through the phishing site to the real site the USB packets for the U2F, and still you know, use it for phishing basically in this way. I forgot if this is just an inherent flaw that can't be patched. I forgot if there was a particular bug that only allowed them to do that. I don't know if that's still possible, but that was very clever, and I thought, oh yeah, that's smart. Doesn't this require additional permission in the browser? Here, I guess here it is. Here's the warning. Wants to connect unknown device. You have to accept that. But it's phishing. You're tricking people, right? You're already on a bad website that wants to trick you. So saying like, yeah, don't accept the USB thing is like, well, like look at the URL. It's wrong. It's a phishing page, you know. But it's a good proof of concept to highlight some weaknesses. It's obviously, or I would assume, not that practical. It's very like advanced. But I assume not many people will do that. But it's like if you like, I don't know, there are some people that should be like this people that program that stuff or design or architecture these things, they should be aware of maybe this possible and of ways how this could be maybe mitigated.
So to summarize, it's good to look at various indications to recognize a phishing link early. Hovering over links, looking at the email where it's coming from, looking at obvious spelling mistakes, and so forth. But once you clicked, always keep in mind to look at the browser URL bar and make sure the domain, the part the browser highlights for you, matches the safe login site you know. And then you should be safe.
Yeah, so that was the phishing video.